All right, welcome back, everyone. This is Payload Pat, and we're back at it again with the another awesome video today, where we're going to be recapping what we did last week as far as our application, as well as more than likely going to try to access some ingress stuff on the Kubernetes cluster, on the Kind cluster. So I'm going to go ahead and get that configured and set up, and just work over some certain challenges that you guys may have been experiencing. So we just want to have like an overall discussion, and just pretty much like a recap, so everyone can catch up who hasn't, who missed last week or who was like struggling with something in particular. So I want to use this time to do that before we go ahead and dive deeper into the next things, which is going to be like config maps. We may even touch volumes, just going over that briefly. So it's kind of up in the air. I just wanted to see where we're at, so we can go ahead and just move naturally from the last call. So with that being said, the floor is open. Does anyone have any certain questions, or again any issues that they have experienced since our last call? Yeah, what's up, Anderson? Okay, yeah, yeah, cool. And again, you guys don't have to
Oh,
be afraid. You can speak up if you want.
hey, can you hear me?
Yep, yeah, I hear you.
I'm sorry.
Yeah, I can hear you. We can hear you.
All right, cool. So, um, I was doing something to where we do a encryption rest for the secrets last night, and I noticed that I was trying to see, have you had any luck doing it with Khan? 'Cause I do know you have to do it in the configuration within the API. For that, do you have to actually get inside the Khan cluster, like in the container, to configure that, or were you had luck doing it to where you was able to just update it using like the K edit and then the or just going to the YAML file in the for the API server to initiate that. Just wondering.
So 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 what was the question? So you say you created a secret and you're trying to edit the secret, or
No, no. Encrypt it at rest. So I know you have to pretty much activate the encryption at rest within the Q API server YAML. Um, I'll try to do it through the Khan cluster, but I'm pretty much trying to access the file, and I'm thinking that I wasn't able to access it. I have to be inside the container itself or inside the cluster itself. So I was just trying to make sure that would you do you have any luck doing that, or have you even tried?
yeah, I'm still struggling to hear what you're saying. So I do apologize. It sounds very faint and like a lot of noise kind of in the background. Am I the only one that's experiencing that, or I want to make sure it's not on my
It's
end?
probably me. It's probably me. 'Cause you're not on my regular headset, so I just asked personally on another day. It's not that crucial.
Okay, okay, cool. Yeah, yeah, we can touch base on it. And go from there. But yeah, so as far as what we had last week, um, yeah, yeah, that's true. You can also type the question in the chat as well. If, we can clarify, because I know you were saying something about secrets and that stuff. So let me go ahead. I just did a push. Updated something here. So last week again, we went over our client cluster. So I have let me see, kgit, kconfig, um, git clustered. So I have a few clusters on my machine now. So we had a kind Kate's cadence cluster. I think it was like kind cluster or something like that. But I went ahead and created a new one the other day. And the great thing about kind is you can quickly destroy and create clusters. So it's not like something that is going to take a while to go ahead and do. As soon as you're done with your testing, you can go ahead and just destroy your resources. And it makes it very easy, to build and test things, especially if you're having something related to like, um, things that have to be like, separate namespaces if you have multiple tenants. So, good way for testing. So right now, do I have any deployments going? Let me see if I get deployed. Okay, I got two deployments in this container and in this here. So what I'm going to do is I've added a few other things, like as I mentioned, as far as setting up the ingress, because last week I had an issue with at the end where you guys couldn't even see the application from that service. Um and I kind of didn't, I wasn't happy about that. So I want you guys to see the process, through and through. So I'm just going to go ahead and quickly create a cluster for you all, and showing you how we do it with the new config here. So I'm going to start on the Flask app version 3, and we'll go from there. So let's go ahead and do that. So just to pull up GitHub so you guys can see what we're going to be following is open up Flask app 3. But before we do that, I'm going to create a new cluster, right? So if you see on our file here, there's a new folder called Ingress, and yeah, we're going to pretty much be using that, right? So I'm going to go into this folder here, and there's a separate Ingress configuration file in here that we're going to be using. So before, the Ingress looked a little bit different. If we see here, it was very simple. We had one worker node, well, one control plane and two worker nodes in our cluster. And now we're gonna have the same thing with the ingress. However, if you look at it, it looks a little bit different here where um, the kind cluster is we still have the control plane and we still have the two worker nodes, but within the control plane there's a couple of configuration settings that we have pretty much for port mappings, and this is going to allow us to use localhost and make it appear as if we're using a ingress. And the whole purpose and point of an ingress is to allow connectivity to those services outside of your cluster. So within the cluster we can just use the service, and we can easily connect to those services based on the service name dot namespace. So say we're connecting to um, let me see, let me go here and show you the Flask app. So we're going in this deployment here, deployment name, oh I'm sorry, service, the service name my Flask app service. So it'll be going to you can do a curl my Flask app service dot default, for example, or just the my Flask app service if we're in the same namespace. But that will allow us to connect to the the pod, which is running on port 5000, and we're pretty much going through that port 30,000, which most of the time if you don't have anything here, you can assign, it'll automatically assign a port number in the range of 30,000 to 32,767. um and if anyone needs a free lab environment, let Idris know. Okay, yeah, Idris, you can post it if you want in there too. Thank you for that. um But does anyone need like a refresher on the what we went over last week as far as what a deployment is, what the services are, or anything that's still like faint to remember or anything? Because again, I want to make sure that you guys are getting value out of this, and if I'm just going too fast, it won't be any value there. So please let me know where you're at, and of course we can go ahead and as far as tailor this call towards that, because this is why we're here. Okay. Looks like Michelle raised her hand. Okay, Michelle, it's all yours.
Sorry, I would like to know exactly if you can go over service again.
What the services? Um,
Mm-hmm.
absolutely. So
Thank you.
you're welcome. It's a great question. So a service is a way to expose a pods or a container. There's application. So we have pods, right? And let me see if I can find like a picture of like a diagram. Services and pods. So I got a picture of one. Okay, something like this maybe. Um, try this, right? So for example, we can use something like this, right? Okay, maybe, maybe not. Maybe something like this. That looks too much. I want a very simple one. Okay, this will work, right? Okay, so as we see here, we have something called a web service, and then we have pods, right? So if we're trying to connect to, a pod, in our case, we have an application that displays the Kubernetes. Welcome to Kate's Cadence, and that is coming directly from these pods or these containers, which are servers that we pretty much packaged from that application the Flask app, right? So now that we have the application and created is in that pod, we want it to be able to service. We want to serve this content to people. So what a service does is um, we're able to communicate to those pods from this web service. So say we're right here, for example. I'm just giving you an example, right? We're right here, we're within the pod, we're within the cluster, and I need to communicate with either one of these pods. These pods are exactly identical. They're just, there's a set of them, right? And we can confirm that by looking at the deployment. We can say we want 5 of these running at all times, right? So for us to go ahead and connect to those pods, um, the best way to do it is to create a service. So pods can change all the time. So to connect to a pod, you can either connect to it, from, the IP address, right? And if a pod changes, or a pod is something happened to one of the pods and we had to delete it and you had to rebuild it, we would always have to find out what the new pod is, in that IP address, or we won't be able to access it. So what the service does is the service allows you to have a direct endpoint which won't change, and it will always be that name space, so that DNS name. So we're going to name that web service. So no matter what IP addresses are within a pod, it doesn't matter, because we're just worrying about what the name of this endpoint is, and the service is going to do the rest for us. So all of these pods down here can get destroyed, and 5 brand new pods will get created. But when we hit this endpoint, it's automatically going to serve us content, because we're not worried about the actual pod's IP address. That no longer matters, and you will be able to get content. And whenever you hit that endpoint, it may be this one, you may hit this one, you may hit this one the next time, but it really doesn't matter, because they're all serving the same purpose and they're providing the same information. So the service takes away that problem of the pods being destroyed and having to be rebuilt, and they have a totally different IP address, which is going to be very difficult to continuously, have to determine and figure out if we had to do this alone. So the service pretty much abstracts that away for us. Hopefully that explained it good enough. Was that a
Okay.
good
Yeah, it was good. Thank you.
Okay, all right, awesome, wonderful. And so yeah, great question on that. Does anyone else have any questions or want to highlight anything else? Okay, Michelle Reeves lowered her hand.
Hey, PJ.
Hey, what's up, man?
Yeah, that was a great explanation. I am curious though, do the
Uh-huh.
services, is there any situation that you've seen services fail or like crash? Because I know it's not running as a pod.
I personally haven't. I don't see anything that would cause it to have any problems, to be quite honest. And of course there is. If anyone else, knows or wants to chime in on that, that's perfectly great. I would love to know as well. But I don't, because there is no like redundancy for, as like you're mentioning, in there that has I'm curious. Maybe is it, I don't really know. Um, but maybe it's built highly available, and it automatically repairs. It should repair itself. So it's auto healing. But great question. You always come with great questions, Jezreel. I love it.
That's
Um,
not actually my actual question. The thing I want you to explain to me because this is the thing
mhm,
that I struggle with is the
yeah.
how the ports get mapped between the pod to the host and then out to the user. So I know like you got the node port.
Yeah.
What does that connect to? And then where does the ingress port, how does that interact with the node port?
Um, so okay, I'm just let's try to answer this here in the simplest way, so we can think this through. So let me see if I can get another picture. These are good questions. Let me see if I can grab another picture here. Of oh wait, I don't know why this is doing that. Okay, cool. It's good to
Note
know.
ports are more local stuff, right? Local
Right,
command.
right. Let me so that's yeah, that's exactly what it is. So um the main thing is, let's go. Do you know the doll? The Chinese doll that it's in one thing. It's like $5 inside $1. So in $1, you open it up, it's another dollar, and there's another dollar, it's another dollar, then it's another dollar, then there's that only that $1.
Yeah. I thought it
So
was Russian.
Rush. Oh, sorry. It's Rush. It is absolutely. Yeah, you're right. I'm totally off. But you get what I'm saying. So the smallest one of those in our case, it's a container, but in Kubernetes, the smallest deployable unit, is a pod. So let's look at it as just that pod, right? But within that pod, of course, we have a container. So that container has a port, right? Because it's its own standalone process, or in its own case, what it thinks is it's its own piece of compute, right? So that has its port. In our case, that is port 5000. Outside of that, we have the pod, right? And the pod has, the containers, they share that pod's IP address. They just are going to a particular port in that IP, so they share that IP address together, right? Outside of that, that pod, you have the node, right? And the node is the host machine, and the host machine is what has its own IP, I mean, its own ports and such, right? That port that the node port is using is just that, it's that port. So 30,000 on that node. If the IP address is 10 dot, that's a private IP, but just to give you an example, if it had a public IP address, it'll, be 10.0.0.1, right? And then colon 30,000. That's how you're able to access that. So as long as I, as far as know what that host port is, I'm able to go and hit that 30,000 endpoint, and then it's going to show me, whatever it's, whatever lies behind that container, which is going to be our port 5000, which is displaying our application as we saw last week. Now, what the ingress does is, it doesn't matter what, the actual like node is, the node IP. It doesn't really see that, because we have, for example, um a domain name, right? Or, like a URL. So say it's, in our case, and in our sample, we're using localhost, but just think of it, it was mywebsite.com. Once we hit the mywebsite.com, what the ingress is going to do, which is a totally separate thing, is it is going to redirect every, let me open up my ingress that we're going to be using. So I kind of wanted to show this later, but I think it's a good question, so we can answer that right now. Let me close this out. Let me go back to my GitHub, show you this. So if I go to my Flask app 3, and I have an ingress, right? So what an ingress is, let's just break it down here. And I actually did it in the README here. Um, I thought I did. I guess not. But nonetheless, here it is. So with the ingress, okay, so we have our ingress called my first ingress, right? So that's just the name. That's nothing normal, nothing abnormal. API version one, all this stuff never really, I won't say it doesn't matter, but it's nothing important to have to remember. But what ingress is, the important things are everything below this. So annotations are important. And annotation, what this is doing is indicating, hey, on this ingress, we want you to rewrite everything to this address here. So um, if you were a, how can I say it? The information is redirected. So we could be going to, uh, 10.10.10.10, um, and then the 30,000, right? We don't have to do that, because this is automatically going to do that for us. It says, okay, if I'm going to, in this case, there's no, there's a host that can go right under rules, and I can specify google.com or whatever my URL is, my website is. And as soon as I hit that, it's going to say, okay, we're going to make sure that, okay, now that you hit it, on this path, because this matches, I need you to take me, if I just put www dot whatever, it's going to take me here, and it's going to take me to this particular service, which is that service that we mentioned, which is going to be not the 30,000, because we're not using Noteport anymore with Ingress. We're going directly to that container. And then within that container, it's saying, okay, we're exposing port 5000 on that My Flask app service. So When we hit this, it's literally just saying, take me here, take me here. And what
Quick
this is,
question, PJ.
what's up?
Quick question. Is the ingress more like in tune with like load balancing to a certain
Absolutely.
extent? Okay.
Yeah, yeah, it's into and low balancing, but because the difference between this and low balancing is the low balancer itself, you can it can serve like only one thing, you know. So the my app service can have this. We can have multiple services, right? So say I have a my Flask app service. Say I have a totally another application, that will have its own load balancer. So there's two problems with that. The first problem with that is cost. You're paying for each one of those load balancers. Load balancers are not free, you know, so you're paying to have that, then that traffic being rerouted as a proxy to those services. And number two, it can be complex. You know, it can cause a lot of confusion, of being able and having to maintain all those things there. So what makes it easier, you can consolidate everything is by using an ingress, because the ingress is saying, hey, I want to go to, you know, the path can be here. I can have it go to slash app or slash this or slash checkout, or this is where microservices and stuff come in, and you can point it to a particular you know, microservice or backend service, whatever that can be. That can be whatever you want it to be, right? So I can literally copy this, and if you see here, this is an array. So I can have multiple paths. So this is just indicating one path, which is the my Flask app forward slash service. Dash service. So when users come in, they hit our website, it shows it here. It says, okay, someone just hit my website. What do I do? Where do I take it? The ingress is pretty much going to say, okay, I'm going to direct this person to here. Now we match the label, so the backend is going to say here, provide me that service. So it's just going to just be just like we're in the cluster, and we just do a curl my Flask app service. But remember, if we're from the outside world, we don't know, we're not able to connect to this locally. So that's why it pretty much does the translation for us, and it gets us that access as if we were in the cluster. So it's serving us just like we normally would. So um long story, I guess short, and I hope I'm not confusing you all more than anything. It is a difficult thing to understand, but just looking back at it, remember, this is the lowest point that we can get, which is the container. And once we get there, the service is going to provide that stuff for us. So and I'll show you all how it, you know, when it switches to actual pod, and then it trickles back to the user. So the user's asking for something, it goes down here. Okay, this matches. So we got there. So now we're looking for rules. Any rule here. So as long as I'm hitting this particular endpoint here, it's going to go ahead and take me here. So we're going to be able to access that Flask app by using that ingress. And again, you can have multiple different paths for different applications. So say we wanted to, again, say this is the main website here. Say I wanted to access Cade's Cadence. If I had Cade's forward slash Cade's Cadence and I had a path for that, it will take me somewhere else. And just like you're looking at this website here, and you know, it just breaks it down for us. So this is pretty much saying that I just entered github.com, and this is what's serving me here, and it goes back up. So the node port is just useful for the actual node, but of course, you don't want, you know, your VIP, and you know that just caused a lot of unnecessary work. And again, people are not aware of, you know, I don't know what GitHub's IP address is, you know, for this server. I just know the URL, so it wouldn't be like friendly for human. It wouldn't be human readable or, you know, convenient for us. They have to put in an IP address, then followed by port 30,000, for example, you know. So that kind of takes care of that. So I probably didn't answer your question, Desiree. But I guess that's the life and the the path in this case of a request from someone from the outside of that cluster using an ingress versus a load balancer, not load balancer, but a node port, which they're not really too much different. Again, node ports, again, it's just host only, and ingress, you're able to actually use like a URL and get us there the same way, and without having to put, you know, append the port number and all that stuff as well, which can be confusing. An average person is trying to go on Instagram or whatever, they don't know to put in a certain port number. This is why we just go by certain paths, right? But that was a very long answer, and I hope.
You did yeah, you did answer it, man. That was great explanation. I can see the difference now between the node port and the ingress. Thank you.
Yeah,
Oh,
yeah,
so may I add to that, if
yeah,
possible?
of course. For sure, for
All
sure.
right. So basically, you know, okay, this is how I look at least from my own point of view, right? So the cluster itself is working just like AWS, right? Think of the Kubernetes cluster as another AWS infrastructure, right? It does have a network layer. It's a whole infrastructure. It's like a data center, pretty much, right? Excuse me. So let's assume you were, excuse me, you were building an application, and that application is living in a pod, right? And it's in your house, right? In order for your customers to access that application you're building, they need that needs to be routed some way outside, right? So think of a service as something that's going to help facilitate that traffic to leave that house to your customer. Now, you can use either a load balancer, you can so the service provide multiple services that you can use, right? One of them is like a node port. You can use a load balancer, a cluster IP, right? Or you could use what they call web proxy, like Nginx, right? Nginx pretty much it's a load balance. I don't, people usually call it like a proxy, but what he's doing is actually load. It can load balance, right?
Hmm.
Like that slash that you look right there, you could create a wild card with that, which is what Pat was explaining. You could literally create a wild card where you can point it to multiple endpoints. It will just use that same route, right? And that's what Nginx is really good for. Another thing that at work you would see, I know that this is like a, um, a CKA kind of class where we're not doing like we are trying to incorporate real world. What you see at real world, you see something like Istio, like those service mesh that comes with like a proxy,
Hmm.
right? Or you would meet something like traffic. That traffic comes with a load balancer as well, just like Nginx. So you have multiple different kind of services. But the takeaway is that services you have multiple different services, right? Like the you could have an endpoint one, which is this one, and then you could have like the node port. The node port just simply allows you to work on like your cube ADM stuff, let's say like the mini cube, and you want to expose that endpoint so that you can see it in the web, right? With just within your infrastructure, within your house or within your laptop, node port is good for that. Obviously, that's not best practice to use a node port to expose your services outside, right? You use a load balancer. Now, some people tend to use Nginx or Traffic because those things are open source. They don't cost money, right?
Hmm.
So if you were to use a service that's a load balancer, obviously you'd be using AWS's load balancer or GCP or Azure, and those are very expensive, by the way. So at
Yep,
work, you see multiple people using Nginx
absolutely.
um, to expose their
So do
traffic.
do they like install Nginx on like a server and just use that as load balancer rather than using the
No,
load
they
balancer service?
do like a
Okay.
they do it as a pod.
Hmm.
Oh,
Yeah,
okay, okay.
yeah. Yeah. Just like
Hmm.
he was showing right there, you can have a whole deployment, and then you have the service that's attached to like a label, right?
Yep.
Like a label, and it would be Nginx, but it's actually a container that's running. Its function is to route traffic from one pod to outside. Because
Yep.
remember, Kubernetes has its own network infrastructure just within it
Hmm.
that's not open to the outside. So what helps that traffic to go from outside? I mean, from inside a Kubernetes cluster to the outside, which is the public, it's a service. Now you can pick and choose what kind of service you want to use. Nginx, node port, or proxy. In this
Hmm.
case, I'm looking over the Nginx as a proxy.
Right. Oh, that's spot on, Anderson, and quite impressed. There's also one more option that you can have as far as a service, but that's a whole nother topic, which is a headless service. But we're not going to discuss that now. We can talk about that when we get into like stateful sets and stuff. But excellent explanation there, and ingresses and stuff. This is honestly, personally, this was one of the harder questions that I've gotten, especially when I was doing my CKA. They asked me a specific question about ingresses and creating an ingress and making sure that the app came and returned back hello to me when I put it in the curl when I curled it. And I was super ecstatic when I saw that hello. It was the most exciting hello I've gotten in a while. Um, but yeah, this is once you get in the thick of this stuff, everything else in Kubernetes is gonna be like fairly, it's still a lot of parts to stuff, but you'll be in really good shape. Um, so what I'm going to do for you all is, and moving on, unless anyone has any questions before we continue, I do want to go ahead and deploy our application again. I'll even run the whole Docker build and everything so you guys can see it end to end by using the Flask app version 3. And then I can show you all how we can start doing like rolling updates and things of that nature so we kind of can, tie everything in together. Um, Let me see here. Give me 1 second. This is something related to work.
Hey Pat, are you using the config file for the Ingress, or are you using just like a regular cluster deployment that you did without the Ingress?
Well, I have to create another. I'm creating another cluster. That's going to have everything I need for the ingress. So if you're going to be following the step 3, we do need to, and I'll detail it in the README here. I kind of just did it on the fly, but this is going to require a new cluster to start the ingress, because what happens is we're installing an ingress controller, um, and an ingress class, and the controllers, just like in any other controller, it ensures that the ingress is running and everything. But the classes, you can have multiple different ingresses, ingress classes. So you may have a use case for a different type of service that doesn't need to use that ingress, but it still needs to use a ingress. So you can kind of have like a default ingress, or you can specify ingress for a certain application. So certain apps are getting, certain traffic and things like that. So um, what I'll do now is, we've already done the install Docker and WSL, so we can ignore this stuff right here, right? But we're gonna work, set up as if it's a brand new install, and that's actually gonna be here. I'm in the wrong file here, which is right here. Okay, so now I'm going to go ahead and create a file, and I'm gonna name it something different, but because I already have that one here. Actually, let me delete the cluster. Delete. Let's find the cluster. Forgot the name of that cluster. It was called Find Ingress cluster here. So you can see me start completely fresh, and it's going to do delete cluster, and I think it's going to delete when I have
I think
set.
you have to actually put. I think you have to put dash name and then the
Okay,
cluster name.
there you go. Appreciate it. Um, find is it this Ingress cluster? Okay. All right. Cool. So it's deleted the ingress cluster here. So it deleted 2 workers in there. So thank you for that layup there. And we're just going to follow along as far as the steps, right? So just like if you missed last week, this is a great way to see what we did. It's just using the 3rd version. So I'm going to go ahead and just copy this here. Just do copy. And then I'm going to name the file here, right? So let me actually copy this first. So let's do a VI for Vim. And then we're going to open a file called find ingress config. And I'm going to paste the content that I got in there here. And again, this is 2 worker nodes and just some extra port mapping so we can have the cluster set up properly. And don't really need to know too much about that besides just making sure that it looks like this here. And then now we can go ahead and do this. We go ahead and go back to instructions. Now we're going to create a cluster here. And I'm going to go ahead and create it. So let's do that. Find dash ingress dash config. Okay, cool. All right, so we're creating a brand new cluster here, and if you want to follow along, absolutely, that's kind of what I want you all to do. So again, watching is okay, but let's get our hands on keyboard, and this is how we're gonna retain that knowledge by doing that. So as you see, it's creating our storage classes, it's joining the worker node, so it's using like the kubeadm join commands. Got our control plane working, so kind is pretty much taking care of everything for us. It's a very nice and an easy way to quickly spin up and destroy a cluster locally. So you can do some very quick testing. Perfect. So now if I do okay, it nodes, you have it here created. So I have named my ingress cluster, my ingress cluster worker, and my ingress cluster worker too. So we have 3 nodes and 1 control plane. Node specifically, and it's for version 1.27.3, which looks good. So now that we have our cluster created, we can go ahead and move on to, where is it? We can move on here, and we've already verified the nodes. So now we're going to install an ingress controller, and this pretty much is going to handle our ingress ingresses and being able to have ingresses run on our cluster. So it's pretty much going to install that on our control plane. And we're going to go ahead and just we're put in this command here. It's actually going to do everything for us quite easily. And as you see here, it created the namespace for us. It created the service account, the rollback, the RBAC stuff. So the role-based access control, config map. So it pretty much created every single thing that we need. So that's quite easy and painless versus us having to do each one manually, which is quite amazing. So now that we have that, let's go ahead and move along here. And it may sometimes take time, but it may already be ready. So let's just run this command here and see. Condition met, so it's actually ready to go. So as quick and painless as that was. So now we have the ingress, the ingress controller set up. We don't have an ingress yet or anything yet, but we have everything as far as the conditions and necessary to be able to have that ingress. So to move on, I'm going to go ahead and start here in the Flask app here. And again, for those who haven't done it, it's okay. We can go ahead and just follow the README and just go ahead and create our Flask app. So again, we have our app here that we're building. It's just may look like a lot of code or confusing for you all, but just to break it down, our application is going to say hello, username, welcome to Gates Cadence, and it's going to also show this is running on pod, and then this should provide us a pod name, and it should also indicate with us what version it's running as well. So that's the main thing that you kind of want to worry about here regarding the application itself, and then we're just going to create a deployment, and within that deployment we can specify the amount of replicas, and we're also mentioning the labels. Labels are one of the most important, I think, is the most important thing in Kubernetes, because if the conditions are met within that label, this is what makes things happen. So this here is the name of our container, which we're going to go ahead and push to Docker Hub in a second. And it's telling it to make sure that that port is running on 5000 as it matches in this service. So we also have resources here and you can set up resources on your pods and deployments. And that's just indicating as we're creating this, we need to make sure the node that this deployment is placed on has enough of the resources that it's requesting. You can still go up and go and use more than 200 like megabytes or whatever that is, right? And that means that this is just a condition for, when a pod is being scheduled. It's not necessarily what the pod is actually going to be using as far as resources after it's been placed on a node. So say it goes over 200, it's not going to kill the node or anything like that, or just cap it. If the resources are there, it will still pretty much run. Just so you guys are aware of that. And disregard the HPA. That's something we're going to move on to eventually. And then again, the port we're trying out again is going to be node port. And the way that the service is selecting the deployment that we're using is based on um, that label that we selected and created, which was app my Flask app. So it's going to automatically bind those two pods that we created to the service because it met these conditions. So it's going to pretty much work. And I remove the node port number from 30,000. So I'm going to allow the node itself to select what port it wants to use. So enough with that being said, let's go ahead and just start creating it. So yeah, let's go ahead and actually get this application Dockerized. So let's go ahead and do that. So I'm in my Flask app version 3. So to create and build an actual Docker image, which is going to bind the app.py and also the requirements together. So it makes sure the application works and it gets what it needs. We're going to do a Docker build, and it's going to be a -t because we're going to tag it. Tagging is important with building a Docker image because it's telling you what we are naming this actual file, this image itself. So I'm going to do the so pvass 24 and / and I think we named it like Flask app or something. Let me make sure I have it right. I'll just copy it. But yeah, it's going to be my Flask app v3. Um, Well, I'm gonna name it PVAS 24, so I don't know if I can skip one of those steps. Someone asked a question here. Crap, you already did this part. Sunday. Can you build it to suppose multiple OSs? So to support multiple OSs? Yeah, we can. I would like some help with that. In fact, so if anyone knows how to do that, that'd be amazing. So I can have a a OS native application, so it works on all. But honestly, at this time, I'm not really sure on how to ensure that works and translates for everyone. So my apologies, Idris. But I'm sure you know how to do it. And if you can get off mute if you want and educate us if you know the process. I really don't know how to do that portion, to be honest. But what this command is doing is again, it's building the application and we're tagging it. So this is going to be the name of the Docker application, and the dot is pretty much indicating where the Docker file is. And we looked at the Docker file last week, but a Docker file is just a set of instructions on what we want the application to do, pretty much. So once that container is opened, run this command, start the actual server. So, and make sure that it's using port 5000. So that's kind of what it is. And I'll just go ahead and show you all that just so you can see what I mean. So from this Python image, do these set of things. So set our work directory to this, copy the contents from this folder to there, and install any packages needed here. So we're actually saying, okay, with this requirement file, open that up, expose port 5000, make sure everything's installed from that requirements text file. And we're actually setting a username, name the user. So we're not using root, which is also a better thing to do as well. And once this application is open, pod this container starts, it should run Python app py, which is going to run our app that we pretty much have created. Oh, it's a process Docker build x build. Is that like a command that needs to be done? Oh, Docker build x. Okay, got you. I'm gonna look at this later, and I'll go ahead and post it. I don't want to break anything in the process of trying to do that, but thank you for that resource, Idris. Um, but yeah, let's go ahead and as far as knock this out now. So I know you guys have been waiting patiently on that. So
So sorry, I have a question. I don't ask, but I have to ask. I don't
yeah,
want to sound dumb,
not
but
never feel like that. Don't feel like that at all.
but but when you say you create a cluster, right, Ingress cluster, so is it different than creating a regular cluster? It's just like in Kubernetes, or does it have to be Ingress cluster and then like a regular other cluster that
Oh,
can exist?
that is not a bad question at all. That is actually a great question, and I'm glad you did ask that. Because we're using kind, it's using Kubernetes and Docker, right? So it's not
Mhm.
officially a real cluster. So there's a lot of intricacies that takes place to where I have to do it this way. So the way we would do it normally, we wouldn't have to, if you were like in AWS and using EKS, for example, you wouldn't have to do this at all. It already will have the, things that it needs to run in Ingress, for example. You will just need to create the controller and all that stuff. But because we're using like Docker and Docker and Docker kind of thing, because it's kind of like um there's the networking is kind of where it causes problems, so that's why I named it and said that. But if for this take for the sake of learning Kubernetes,
Mhm.
there's no cluster that's only specifically for like Ingress, or a cluster that's for like non-Ingress, so Ingress won't work on
Okay.
it. Yeah, so a good question though.
Thank
Yeah.
you because I was so confused.
Yeah, I'm so sorry for that. I should
No, I was gonna ask Engineer Idris in private, but I was like, you know what? I want to know.
No, ask away, because you may
Thank
forget.
you.
So if you have
Thank
any
you.
questions like that, other people are probably wondering the same thing. So it's fine. So I'm gonna go ahead and run this, right? It's probably going to show that it's already cached, so it's probably going to go really quickly, because we've already did this before. Um, for example, here. So, but I did no cache, so we should be good. But there you go. You have everything submitted there. And dog, my girlfriend just came in. Hey, right. So that's been installed. So we have our Docker image there, and we can then do like a Docker PS. Do Docker PS. All right. I have a lot on here, so you can disregard that. But this one, where is it? Oh my gosh, it's quite a bit, and it doesn't even look good. Um, because I have it, I'm zoomed in quite a bit. But the Docker image, I don't know why it's not showing the name good, but it's in here somewhere. I don't know. I can't see it for some odd reason, but it's been created and it's in here, right? But the more important thing, if you're doing yours, you will probably be much easier to see. But the more important thing is we can do I want to do a Docker push. So essentially what I'm saying is I'm pushing this Docker image into my own registry. So if I do Docker push, and then the same name as what I had before, which is this. If I could just do version 3. So Docker push my image, my Flask app v3. It's going to go ahead and push that to my Docker hub, right? So again, these already exist because it pretty much had the same baseline essentially. So just making those changes that I made from the last push. So now if I go to my Docker Hub account, right? If I go here, it should show that I just uploaded Docker, my latest Docker, my Flask app, right? So as you see, it says less than 1 minute ago. Um, and V3, right, a few seconds ago. So it pretty much is updated here. So initially, if you haven't signed into Docker on your console, you just sign in like you would normally, your username and password, and it should be able to go ahead and push right through for you. So now that we have that, right? So now we have our Docker image. So let's go ahead and actually start creating our deployment in our cluster. I mean, in our services and all that other stuff, so we can get this app running and getting that Ingress running too. So so I'm gonna clear that up, and I'm gonna do a kubectl create minus f. So we can start off with the deployment and go from there, right? So my Flask app is created, so we can do kgit deploy, make sure those loaded up. Like something is going on with it. Okay, there you go. So now it's 2 out of 2. So ready again means that these two pods um are running, and we can do kgit pods, and we can also confirm that as well. So each one of those are running fine, which looks beautiful and amazing, right? So now what we want to do is create the service. So create service. Well, create minus f, and I think I named it my Flask app service. All right. So if I do kgit svc slash endpoint, so we're getting the service and the endpoint. And I kind of mentioned that last time. The service and endpoint are important, right? So the service is the service. It's going to go ahead and provide a way to reach those pods, right? And the endpoint are those pods. So if you look at here, we have two endpoints, which are going to be those two pods. And if I do a get pods um, dash minus o wide to get more information. These should match. So 10.244.1.3 and 2.3, right? And again, it's showing on port 5000. So all that looks good. And Kubernetes automatically has an endpoint which allows all pods to communicate. This is what this is for. Perfect. So that's that. So now we have our service and we have our pod. And the difference is now we're able to connect to this locally. So if we can do like a curl, whatever, we can create another pod and we can access this without a problem. However, that's not necessarily what we want to do. We want to be able to access this from like our local host, right? So to do that, this is where the ingress comes in. So, and as we see here as well, instead of it using the 30,000 that we had set up for it um, in the file, the manifest file, it just gave us a random number, which is 31,383, right? So let's go ahead
Hey,
and
quick, sorry to interrupt you, right?
oh, do your
You
thing.
go too far. I wanted to point something out, right?
Hmm.
You notice how when you created the container, right?
Hmm.
You couldn't find it, right?
Hmm.
Because you had so many of them. But
Yeah, I
when
need a few
you
up.
created it in the cluster, you could pinpoint exactly where it's located, right?
Yep. Hmm.
So what we're trying to point out here is that that's the reason of Kubernetes, right? It manages those containers. That way, you are not wasting time. Like, oh, where is it?
Hmm.
You see what I mean? Just
Yep.
little things like that. Like, I can see my container. I don't have to go look for it.
Yep.
Right? I know exactly where it's located. I just wanted to point that out, just in case people are like, wait, why is it that we can't just create a Docker container and use it? Why is it, there's Docker, but why, some people really don't understand why is it that we have Docker and then we have Kubernetes. So
Right.
that was
It's
this was a good use case, what you just pointed out right there, that
yeah.
you were looking for that container that you created, you couldn't find it. But with Kubernetes, you can literally see where that container is located.
Right. And this was a mistake that I did as well. I did Docker PS. So Docker PS is pretty much showing all the
Everything.
running containers.
Exactly.
So I
Exactly.
actually just created the image, and I did not create I didn't actually run it. So remember
Oh,
a
that's
running
right.
image of
Yeah.
Docker is a
Hmm.
container, but a container
Right.
that is not running is just an image. So hopefully that also
Image.
clarifies some stuff for you as well. So if I do Docker images,
Right.
that should actually show up now, and it should show us the image that we actually just created, which I did quite a bit of times. But 7 minutes ago, this is the one that I was looking for, my Flask app. And as we see
Mm,
here, the tag is version 3. So, but nonetheless, what you said is exactly what happens, especially if someone who's developing multiple apps and multiple versions. Say
mm,
you need to change a particular app that you can't even really find anymore, and it can get very ugly very quickly. So yes,
yeah,
Kubernetes is the orchestrator of this. It pretty much does all of the hard work or the undifferentiated heavy lifting for us. And we kind of just worry about creating the app, and Kubernetes just makes the desired state that we want to have. It just makes sure
exactly.
it does its best to maintain that.
Very good point.
Perfect,
And
perfect. So yeah. So
makes
thank you for mentioning that to me as well.
no
Um,
problem.
so yeah, so we got the service, we got our endpoints, and now we want to be able to so in this case, I'm gonna do something like random, right? So I'm gonna create a pod. Let me do this. Let me do qtl create no qtl run. Hey, Ed1, can you mute? We're getting some background noise. All right, thank you. So we're gonna create a. I just want to create a pod, right? Because remember, pods inside a contained in a cluster, all pods are able to communicate with each other without any problem, right? So I want to create one that's inside the container. We're able to go ahead and run a command for example, like curl. So we can curl it internally, and then I want us to be able to, as if we're a person on a web browser doing the same thing. So you can kind of see where the service takes place. And then where the actual ingress will take place, right? So I'm going to do this before I create the ingress. So kubectl run, I'm gonna just name it busy, and then dash dash image is equal to busybox. And then I can do run a command. So I'm gonna do sleep 1 day. Just do this just in case. And I'm just telling it to create this container, well, create this pod with this image busybox, and I just need it to sleep for 1 day, so it doesn't just shut down automatically, right? So now I have that pod created, so I can do kget pods have you okay, and I named it busy, right? So we're gonna do a k exec, which is going to say, hey, I need to get inside this pod named busy, right? So I can do minus it, and that means I'm getting a interactive mode with it. So I'm able to go ahead as far as execute like commands as if I'm like inside it. Like if you were to SSH into it, that's pretty much what we're doing. And then we're gonna name busy, and then what command do I want to run in here, right? So I'm gonna just do a shell. We're gonna open up a shell command. So now I do ls, and we can pretty much do whatever we want, right? So what I want to do here is do a let's curl, um, and we're gonna name of the service. So the service was named where is it? Okay, my Flash service app, right? Let's see here. Curl is not in here. What about WGet is not in there? That's why I don't like using curl all the time. So there you go. There you have it. I'm gonna exit this because I don't even have to just install curl. But let's do this. Next, I name this engine. No test. And we don't need this anymore. Because Nginx is just gonna run its Nginx thing, right? So, but we're gonna do the same thing. We're gonna exec into it. Okay. Okay, I need the test, of course. Okay. All right. So same thing, right? So I can do a curl my Flask app. Should work. I'm gonna mute you.
Hey Patrick, Sally's trying to get in. I don't know.
In the I mean, it would show. I have it open, so I'm not sure why she's having trouble.
If you go where it says invited, she's showing up over there, but she can't get in for some reason.
Invited Sally. It has to be some issues she's having in like on her
Yeah.
side.
Okay.
Um, yeah. I mean, she can keep trying, but maybe try the browser if she's not using the browser.
Okay.
Um, but yeah, sorry about that.
Sorry about that. She keeps pinging me. That's all. She really
Oh
wants
yeah,
to
I see the
flash.
amount of requests she's doing. That's odd though. But we should be able to curl um the name of the service dot domain. And again, I don't know if I made a mistake. Not a mistake, but there may be an issue as far as with how I set up the cluster where it may be acting weird. But it should be able to give me that. Yeah, it's not. Don't know why it's doing that. Exit. Oh, that IP. Let's see if we can curl the IP here. Let's try this. Oops. Um, or minus seven. Or, all right. So not sure why the DNS is not capturing it. I might be doing something wrong. Um, the curl. That can't be default. Uh, Name of the service. Let me just try this. Yeah, it isn't. It doesn't work. Something's going on. I think I'm doing something wrong. But in any other situation, it would pretty much do the same thing as we see here. Though we're able to curl and oh, I'm not doing the right port. Um, we will be able to curl this, right? So it says the default user. We didn't specify any default user or username or anything like that here, and it tells us actually what pod we're running on here as well, which is awesome. So that's good. So I'm going to exit that. That was just a simple test, as if we're within a cluster. But now, if we're a person outside of a cluster, we can't curl, that service name dot dot 5000. Well, port 5000. So to do that, we come into play as using the ingress. So we could do with kubectl create ingress. So minus f, and I name the ingress. I believe it's not YAML. All right. So get. All right, so now we have the ingress called my first ingress. It's using the Nginx class, and it's pretty much saying all hosts, and it's using port 80, which is going to be the default port once we get to the ingress. So what I can do now is do this here. Should work now. Localhost. So this is pretty much what's happening because I'm on my actual local domain and localhost, and if we look at um the pod the settings that I have here in the ingress. So let's describe it. Describe ingress. First ingress. So we're using the my first ingress. The address, you see what it says? It says localhost because I just did I didn't specify the path to a URL. It automatically is assuming I'm using localhost because it can't get anywhere else besides my localhost. So in another case, what we would have here is www dot whatever we put in there, and it will pretty much redirect us there. So because I did that, when I went ahead and just put in localhost, it automatically redirected us to where it says, take me here to the My Flask app service. So that My Flask app service has what? Two pods. And those two pods are these two IPs. So pretty much it's just utilizing the service. So it's going from the ingress to the service to the pod to the container, if that makes sense. and that takes away all of the confusing stuff. So say we had another set of pods, and we can even do this to where we want to have the path here, and I can make another path saying old Flask app, right? And I can create another deployment, and I can say, hey, I want it to go to the old one. So whenever I do a forward slash like old, and I guess we can do that now. um Let me see the Flask app version 2, and this is where things get fun, where you can just start testing things out, right? So we're gonna cd the Flask app 2, and I'm gonna do a k create. No, yeah, k create f deployment YAML. But you guys are gonna see something interesting. I'm gonna have to change some things up here. Yeah, it already exists. So let's edit it. So I'm gonna edit the deployment because the name of the deployment is the same. So k edit. Oh no, deployment YAML, and I'm gonna name it my Flask app deployment. I'm gonna do like slash v2 or something so we can differentiate it. So slash v2. So version 2. But I also want to go ahead and change the labels. I'm going to add a label here. V version 2. Right. Paste it version 2. Let me correct this stuff. Version 2. So now these are going to show version 2. I create that app. So let's go ahead and save this. Okay, create -f deployment. Yeah, version 1 can have deployment. Match label type string. Where did I screw that up at? So we got here version 2. That's looking for a string. All right, cool. So now we created the version 2 app, right? So if I do a k create service, so I need to create a service as well. So I can do a vi service on here, my Flask app service, and I'm gonna have to change a couple of things on here, right? So in this case, I want the node port to be selected by itself. So I don't want to choose it. I want it to choose itself. And then we can also do node port. That looks good. But I also need to do this. I need to go ahead and add the version. So version, and I'm gonna do 2. That looks good. So okay, create -f, my Flask app. Here. Named it. I need to rename it too. Then Flask app service. Let's put that should be 2. 2. All right. So the service is created, and then so we do kget pods, right? Well, kget services. So we should have my Flask app service, and we have a my Flask app service of a v2. So I'm gonna end up renaming that to like service like v3 or something so I can remember. But essentially what we're doing is creating those two services. So now what I can do is I can do a let's go ahead and edit the ingress. So I'm gonna cd back into Flask app version 3. Oh, somebody has a question. I'm sorry, I didn't even realize that. I was in the weeds. Idris, what's up? Sorry about that. Idris, you there?
Idris, you there? Yeah, yeah. Sorry, I was looking for the mute button. So the question I have is for the ingress that you created, right? So
Mm-hmm.
are you using are you attaching the expose port in the ingress, or you're attaching the actual container port in the ingress? So you
Um,
see how you have your port 5000 colon. Are you using 5000 or you're using the 31383?
it's gonna be
It's going to be, oh, 5000?
yeah, it's gonna
Yeah,
use
it's
five.
going to use five. Okay.
Yeah.
Then my next question is, I see that you're using like when you're creating a new service, right? You added like a version. So where is
Hmm.
the version coming from? Sorry, I was doing something else, so I skipped that.
No, you're good.
No, you're good.
Good question.
Good question.
Um,
Um,
well, when I
well,
answer,
when I
can you
answer,
mute
can
it?
you mute it?
Because we kind
Because
of getting
we kind of
feedback.
getting feedback. What?
Can you mute
Can you
yourself?
mute yourself? Oh,
Because
okay.
we
Because
getting
I
feedback.
get feedback.
All right, awesome. Thank you. So, no, good question. So the version is just a label. So in this case, I use version 2 because the initial label on that, it would have made those pods that I created for that are version 2, it would have binded to the actual my Flask app service. So because it matched those requirements, and if you see here, if I do kgit um, service for and also endpoint, wait, why did service 2 not show up? Did I? Let me do kgit pods. Didn't crash loop back off. Oh, do I have a version 2 in there? Let's see. At EI deployment. Let me see what I did wrong here. CD dot dot Flask v2. I Flask me EI deployment. Image pull policy always. So saying crash loop back off. Why though? Let's see. Let me see what's causing this. So this is a troubleshooting method that we can go ahead and do, right? So let's do let me do qctl logs and then the name of one of these deployments so we can see what's causing the error that I've made here. Unknown. Okay. So I'm going to have to update the invalid syntax pod name. Okay. This is something related to the actual image. I end up doing this. I'm probably going to remove it now just to show us process, but let me do it on version 1. So something. Oh, you cleared the question. But the reason why I made the label is just the reasons to again just separate the differences between the pods because remember those deployments that we've created, they have the same label. So if I create another set of pods, even though I changed the name of the deployment as well, those are still going to bind to that service, which we didn't want. We want to have two separate services. So um, those pods that are just going to the forward slash are going to be served by the version 3 deployment pods, and then I can just do like another name like forward slash old or something like that. But in this case, let me just do version 1. Of course, Idris. Amazing question. I know you've been waiting since last week for this, so as well as network policies, which we'll get into as well. Um, but that is cool. Let me cd to folder version 1, and I probably did this for the same thing as version 1. What is different? Cd back ls cd to Flask app. And let me just cat the app UI. Version 1 doesn't have it, so we're just going to do version 1. So I'm going to modify deployment, YAML, just name it to my Flask app version 1 or something. Um, and then I'll fix version 2 the next time you see it. Mint dash v1. Then we just need to add another label here. I do version, then 1. Then here it'll be using the same thing. So just this, paste that. And then now this one has to, because the service has to match both of these labels. It can be one or the other. So now this should be good. And let me do VI service, my Flask app service, name it V1, V1, and then node port. I can just have it choose what node port it wants to use, and then app. So do the same thing. Just undo. Version 1, and then I can do K create minus F deployment, and then so Flask app service. Did I update the service already? Yeah. So now if we do K get SVC, we should have like multiple, right? So we have three. Um, don't worry about V2 right now, but let's do K get service and endpoint. And now you see if we disregard this one, because I had the service labels updated to V1, they didn't connect to this one because of the service labels didn't match. So that's why it's doing that. And it's like someone else said something. Oh, okay. All right, cool. All right, perfect. So moving on, I want us to go ahead and now update the ingress, which was the main thing, right? So let's go ahead and edit the ingress. So I'm going to CD back into the Flask app version 3. And then I'm going to VI edit the ingress.yaml file so we can make some changes, right? Okay, so now that was the first path, right? So this, I'm going to paste this here, right? Right, perfect. All right, cool. So now instead of it just going to forward slash, I'm going to name it to forward slash old. And this can be anything that I want it to be. I just wanted to reference it to old. So the backend service now, the service thing that we're looking for is my Flask app service. And it's going to be what dash V1 because that was the first one. And now once we get into this service, we need to go ahead and make sure that it points to port 5000, right? So that's really it. So we can go and continue to make multiple different paths. It's pretty much up to us. But let's go ahead and I'm going to save that and I'm going to do a K replace. So we can replace resources, which essentially what it's doing is it's going to do a kubectl delete the name of this service, I mean the name of this resource and replace it, which is going to be K create. So it just binds and connects the two commands in one. So I don't have to do a delete and then a create. So K replace minus F, the name of the file, which is going to be ingress, and that can be dash dash force. We want to force it to go ahead and do it, and also dash dash grace period is equal to 0. So I don't want to wait because usually if I didn't do the grace period, it's going to wait 30 seconds because it's trying to do a graceful close. The grace period equals 0 is pretty much just killing the actual it's using a kill process. So we can go back and okay, get ingress. We still should be good, right? Okay, perfect. So now let's go back here, right? So I'm gonna go back to localhost. It shouldn't do that. Why did it do that? To old, but I think I'm gonna like a brand new one because I think it's like localhost. There we go. Okay. So I think it's caching stuff in there. But as you see here, I entered localhost and it's taking me to this version. I know what it is. Let me edit the service because it actually is matching because they're matching both. It's let me do this K get service and I'm literally just learning this as we do it. Um if we see here, it says these four are also going to 1.6 and 1.7 because I have that label. So that label, I guess it's either or it matches. So we need to edit the service on both of them. Edit service. Let's not do that. So okay, edit service, and I'm gonna name it my Flask app service. And this one here, selector, right? Is I'm gonna remove this to just show version instead, so it won't match the other one. So I'm gonna do version E3. Save that. Ooh, name it the same way as the other ones. But as you see here, the labeling is pretty much what dictates, what things are gonna apply to. So if it applies to me, I'm gonna it's gonna affect me, right? So if I do kget service now, it should show nothing for the third one. Oh, it's only one, and it's 94.20, which is that one. Okay, but why is it just one? Um, oh, they get endpoint, my bad. So I want to get the endpoint. And as you see here now, only the service one is working because the the pods that I have up there, they're not the same. So I'm going to edit the deployment, and then it's going to be Flask app deployment, right? I'm going to change the label to, so I can save it. I'm gonna do VI deployment. It's probably easier this way. So instead of the label showing here, I'm gonna name it version 3. Version 3, and then version 3. Version 3. And we're gonna do the same. Okay, replace and stuff. Dash force. Dash grace period equals 0. All right. So now if I do another kget endpoint, right? Now we see those two connected to that one, and now this service v1 is connected to that one. So now if I do this and go back to our localhost, I can show if we go to only selecting localhost, it should always show version 3 every time I refresh it. And also, if you notice this, the name of the pod is changing. So it's switching between the two, and that's just where the load balancing comes in place. So yeah, we may be hitting the same app, but again, it's letting us know which pod we're running on as well, which is pretty amazing as well, right? But now if I do a / old, which is going to show us the old service, which is going to be version what? 1, right? So now version 1 is showing here. So whenever I hit this endpoint, version 1, version 1, version 1, version 1. But as soon as I do localhost by itself, it's going to show me version 3 because we have those services listening essentially to that particular path. So as soon as someone hits that path, it's saying, okay, this path for old, we're going to take you to version 1, and the same if I have version 2, which I need to change a line in that actual app, which is broken right now, but it's the same process, it's the same thing. So did that make sense for you all, as far as the ingress and how it's providing traffic and making the actual changes and everything? Does that make sense for you all? Hope I didn't lose you all.
Makes perfect sense.
Awesome,
Yeah, it
awesome.
makes sense to me. Mm.
It does. Okay, cool, cool,
Just
cool.
gotta try it, right? We just gotta do hands on.
Yeah, because as you see, guys, I've made mistakes in here as we're doing this, and it's okay to make mistakes. It's just the process of, your thought process of how to see what the issue is. Because I didn't know that the pods, as long as it matches one of the labels, it's going to be considered, as a selector. So that's something that I didn't know, and I just learned troubleshooting and working with you all in this. So you learn something every day. Every time you try something new and different, there's a new thing that you can find. So continue to find all your nuggets. The more you dig, the more you find. So that's the way I like to think of it. Quick question. Yep, Idris, all yours. Idris, the code is terrible, so don't judge me. So how do you store the environment? Which, well, I have default values in the environments in there. So in case I didn't specify anything, it automatically goes to the default of that. So yeah, it's probably something I just gotta fix that's weird, whatever. But yeah, you can help me with that if you want. I just wanted to be able to pull the environmental variable. How did I get the pot name? Good question. So Kubernetes, what we have here is, and I'm going to open up that file here so you can see. So if we look at the deployment, so cat deployment, right? The deployment, oops. There is a environmental variable here that I'm using, and it's using pod name. I named it pod name, but value from and field reference, field path, metadata name. So what it's doing is within a pod itself, it's actually pulling the information from metadata.name. So if I do, for example, a k get pods, right? Let me do k get pods, my Flask app, right? And then I can do 580, whatever, and then 9 or something. I'm just using one, right? And if I do a um, minus output YAML. If I do minus output YAML and then no minus output JSON path, and you guys will get this sooner or later, but it's gonna be dot metadata dot name, I think it is. Probably did this wrong. Did it wrong. Let me move this out the way. Dot metadata dot name. I think it's gonna be here. Right. I think this is how you do it. There you go. So this is pretty much where it's pulling that environmental variable from. It's using this essentially. So that's how it gets that name. Um, because if you go ahead and just do dot metadata, you will be able to see like everything as far as the metadata within that pod, which is a whole lot of stuff, right? And then I'm just parsing for the name itself. So that's why I did the dot name. So, but that's a whole nother process and way of learning that. Um, this took me a little bit of while to understand that portion of it, but not necessarily too important. But yeah, it's probably something that in my development. Um, and I've learned new stuff. Of course, Idris, if coming from you, I'm hearing that we must be groundbreaking stuff. So that's really amazing. That you learned something. So I'm really glad, and I hope others learn as well. And we're going to build on top of that. And you bring up another good question as far as the how are we storing the environmental variables. Next week we can talk about how we can use other options, because just storing environmental variables within your code is a big no-no. And what we can do is create, though we can inject those environmental variables within a couple of ways. Like you noticed in the environment where we did the env, it's pulling the information right there in here. So in this method, I just enabled and I just entered the environmental variables here. However, there's another way you can do it where you can create like a config map, and you can reference a config map in your container. So say you have an application like what would you say, like a MySQL server. You can specify the port, the endpoint, the username, and password and stuff that if you want to do that, it may not be the best thing, but at least the username and stuff you can use. But maybe if you want to have the password, like not in plain text, you will be able to create like a secret, and then that's where you can inject secrets as well. And we can kind of talk about that next week. What my goal is to do is we can start discussing resources, and we kind of went over it a little bit today, but we can talk about how we can start doing like HPA, which is horizontal pod auto scaling. So we can auto scale and grow our nodes based on the amounts of requests that are going in. So we can make sure that we're, expanding and scaling and being elastic. So when traffic expands and increases, we can go wide and we can increase we can horizontally um, add another node to make sure that the traffic that we're getting is able to be served appropriately. Can we all try to deploy a microservice ourselves before moving to a new topic so we can reinforce what we have learned so far? I love it. Yeah, yeah, we can definitely do that. And again, uh, when he says microservice, that literally is what we've just did. That's the service. It's serving a web page. So let's create the version 1, version 2, and version 3, and add that in our paths, in our ingress, and then that will allow us to reconfirm. Okay, I challenge you all to name it something different. Something as simple as that will let you know what you're doing and how it's pretty much going through. So the options are endless. I'm trying to do as much as I can with the application that we have, and again, it's something that we can just grow from. And I'm trying to like use and reference all the important topics because this is um a lot of things to learn. But the smaller we do it, and the more we expand it, the better we can reconfirm, so we can just build from last week to this week to next week. And if anyone has any suggestions on how to do stuff better, or they want to do something a different way, I don't have to be the only one talking. I know me and Emerson and I talked, and Idris
So
as well.
I want to give some input. The reason why I said that is because, since, some people are like, learning Kubernetes from, beginner, so it will be a good idea for them to kind of, do something by themselves, be able
Hmm.
to deploy a little application on their
Point.
cluster. So before next week, then if they have any question, they can kind of ask that, okay, this is the error, I'm getting, stuck at. So that way, before, a new topic is dropped, they already, how to, at least deploy something by themselves, understand, whereby they can kind of, replicate the same thing over and over again before moving to a new topic.
Totally agree. I agree with that, wholeheartedly. And that's why this week, some people may look at this and like, well, we kind of didn't move on from what we did last week, which is true. However, reconfirming, redoing it ourselves is going to just reinforce our learning. So that's why I don't want to just speed through and start talking about other things before we kind of get where we're at and now, because we're just going to be playing catch up, and that's not the point of this. We want you all uh, to practice. That's the best way to do it. Start breaking things, and see what the issue is. Just like I looked at the logs from why the version 2 wasn't working, I'm gonna go ahead and now start doing some debugging and troubleshooting, and I see what the issue is because it pretty much was verbose on what the problem was. And that's how you build. That's how you create, because um, not doing anything is not going to help you. So, watching a video is all cool and all. But I expect and I demand you all, create these clusters yourselves. And it's only going to help you, you know what I'm saying? Because I'm doing this, reinforcing it for myself is very helpful for me personally. But, again, getting the use and adjustment to simply understanding YAML files, the more you get into these things, you're gonna get that muscle memory, and it'll be a lot easier the more you do it. I promise you. Yeah, Elijah, you have a question?
Yes.
Sally never got in.
Just yeah, hello, can you hear me?
Yeah, yeah, we can hear you. What's up?
All right, yeah. Just to add to what Idris said, Idris that just spoke last. Yeah.
Yeah. Hmm.
Yeah, just to add to what he said, I did do some hands-on over the weekends, and I was interesting because I was having really big trouble trying to work out my WSL on my Windows laptop. And
Mm-hmm.
after a lot of troubleshooting and communication, I was able to set that up. And I also got the idea because I saw someone on the platform saying, "Oh, I installed Red Hat," and I was like, "Oh, looks like Red Hat used to be the major what you see on the real life, like on
Mm-hmm.
an enterprise deployment.
Environment.
That's what environment. That's what you definitely find out common." So I installed that, but when I started um, when I installed the kind clusters, it did come out right. Like I did different configurations and tried it out. But what I also noticed is every time I kind of like close my terminal and try to bring it back up, I don't have access to the clusters I've created, and I'll probably need to do like a delete and then um, create another one again before I can have access. So I don't know if that's how it's supposed to work or um, yeah.
Wow. Well, no. It does not supposed to work like that. You should be able to um access this cluster. And what happens is it should create a like a cluster role binding or service account or something like that where you're able to access. And I'm very interested to see why, like what error is saying. Is it giving you like a 8080 issue or something like that where it can't find it?
No,
What is it
no,
saying?
it just saying I'll just pull it open. So when I tried, like I did kind get notes and it wasn't bringing anything up.
Mm,
Um, and then the error was let me see. Yeah, okay. The error was like error 0 1 1 1, and it says um
you can
couldn't get current server API group, something like that.
send
I'll
us a
just
screenshot. And whenever anyone is having problems like that, send us screenshots so we can see what what issue is, and we can kind of like work a little bit easier and better, because not only myself can help, others can help troubleshoot. And it looks like someone mentioned that it looks like it may be a issue with Docker, which could definitely be the culprit. But yeah, it's odd that it
oh, okay.
works.
So if the yeah. Okay, yes, another thing also is do I need to always start up my Docker desktop before this or
Yeah, yeah, because Docker in kind, it's Kubernetes in Docker, so it's
yeah,
relying on the Docker to be running, so because it can't find the container, or it can't find the cluster because it's not active, it doesn't exist at that point.
good stuff. Yeah, I just figured it out now because
There
my
you go. You see.
yeah, yeah, thanks. Yeah.
No,
Alrighty.
you see, that's a really good question. I do remember that you mentioned that this weekend. So thank you for letting us know what troubles you were having rather than just waiting, for some help. So if and
Mm,
that goes for others, you just ask that question and look, someone already answered. So shout out to Soho for answering that and finding out what that problem was right there. So it's a community and we're all here to help one another. So someone may be good at one thing and someone may be the master at something else, but together we're gonna sharpen each
Yep,
other with that.
that's amazing.
Hmm. Hmm.
I wanted to show something back if you don't mind.
Sure.
Um,
Should I stop recording?
yeah, you could start recording so it
Okay.
doesn't interfere.
Yeah, cool. So for those who are watching the recording, definitely check out our session next week. Again, we do this every Wednesday, and come as you are. We are excited to have all those interested in Kubernetes and on the road to our CKA. So you guys have a good one, and we'll see you on the next vid.